I'm Cagatay. This is Dash, you probably know. And this is Yuho, our mascot, Wolt's mascot. And I live in Helsinki. I'm from Turkey. I'm a Flutter and Dart GDE, and currently Flutter Competence Lead at Wolt. So today I'm going to talk about reactive navigation. So 3 parts. The first one will be problem description. So what is the problem that I'm going to touch today? State management and app navigation. These are really hot topics, we know. And then fundamentals. And then next will be my demo app. It will be the demonstration about what I will be showing. Let's start with the problem description. So Flutter Full Stack Conference, and Victor is here. They organized a coaching session. It was amazing coaching session about how to give a good talk for speakers. And I really liked one part of it, frustration. Sometimes it's okay to frustrate our audience because frustration drives actions. And I hope you don't mind a little bit frustrations. I hope you're ready. Because state management. How many of you are frustrated with state management? I don't know. But it's the hottest topic in Flutter community. If you are a Flutter developer, you probably know Mike, Material Mike, also known as. So he makes a list of these state management packages. And see here, 30 of them. There are more. He ranks these packages based on likes and open issues and some other criteria. So what is the problem there? The problem is that there are many of them, and sometimes developers are over defensive about these packages and sometimes emotional. And when new Flutter developers, they start their project, they start Flutter, they feel like they have to find the best state management before starting their project. And they ask everyone in every occasion, in every meeting, which state management are you using? Which one I should use? So this is a bit frustrating for many Flutter developers. Yeah, when I look at this, I also have some frustration. But there is more frustration coming. And again, from Mike, there are 30 navigation packages, and there are more, of course. So for a long time, Flutter used imperative navigation. And in 2020, they announced Navigator 2. Who are familiar with Navigator 2? Okay, even here, only a couple people. Like, it is found very complex when it was announced. And we have seen some opinionated alternative solutions as stated in here. Again, people are asking, which navigation package should I use? And this is my take here. I shared this on Twitter. So building navigation API for a cross-platform solution, it's not easy. It's naturally complex. And there are 2 types of developers. One, I'm one of those, who find this, yes, this is naturally complex, but Navigator 2 is not that bad. Just give some time, investigate it, understand it, read the source code. It's not that bad. Actually, it's brilliant. It's one of me. But not everyone thinks the same. I respect that. And there are other types of developers who don't want to even read this complicated documentation, and they keep with alternative packages or Navigator 1, which is also known as Navigator 2, imperative navigation. But yeah, this was the frustration part as suggested by the coaching. Now, this is the Turkish poet, Nazım Hikmet from Turkey. After this frustration, he says this: the most beautiful sea hasn't been crossed yet. And the most beautiful child hasn't grown up yet. Our most beautiful days, the ones we haven't seen yet. And the best state management solution is the one has not been implemented yet. Why I think this way? Because I tried many solutions, and I'm pretty sure you already know many alternative packages, and you're asked this question. I tried many of them. I came up with my own solution, but every new thing was better than before. And during all this time, what matters was that I was keep delivering, but I was growing as a better developer. So it is not a showstopper if you don't know the perfect state management, if you don't know what it is, if you don't know what it is. Just keep delivering. I will start with the second part, fundamentals. Because we are going to talk about reactive app navigation. Again, I'm going to present you my approach, which is not perfect solution because even today on the plane, I was correcting my approach. So this is based on my learnings, where I stand today. But whatever solution it is, we should stick with the fundamentals, such as maintainability, scalability, testability, readability, and also architectural patterns such as dependency injection, separation concerns, separation of concerns, and so on. But reactive navigation management, what do I mean by that? So it's about handling navigation in a way that it responds to the changes in app states or some intents coming from operating system. And navigation is actually at the core of our application. It touches everywhere. It's the one of the root router is at the root part, like inside material app. So having a good navigation solution requires a good understanding of application architecture, state management, MVVM pattern, and Navigator 2. We will go through these. These are, for many people, very simple things, but I just want to go because there are people with different levels, but this is how I see the architecture, how I summarize a good architecture according to my experience. So let's start with the data layer. These are the keywords. So when we ask this question around in interviews, like just what is the data layer? What do you understand from data logic? So it is about how the data operation is handled without concerning why. And these are the things like operations, CRUD operations, create, read, update, delete. Abstraction is a keyword, hiding the complexities of local data source, remote data source. And repository is the orchestrator of the interactions between these data sources. Cache manages the local data source. Remote manages the external communication. And then we have the domain layer. This is about the why the data operation is needed and what the outcome should be. It's the brain of the app, and the decisions are made here. These are business requirements coming from our designers, product leads. We do some operations, data operations. We reuse this data based on the requirements. And inside this layer, some people choose to have use case classes, which are single operations, like business scenario, or some choose to have service classes, which they group operations under one context. And then we have entities represent the real world business objects. Then we have the UI. We are getting closer to the state management. This is what the UI should display according to the current state and with any changes to that state. And this is the formulation that many Flutter developers are familiar. You have the state, and UI is the function of your state. The function is the build method. You compose your widget tree according to this state. And we have V models or stateful widgets. They are the stakeholders. And state management is the efficient state management is the one that prevents this unnecessary rebuilding of the widgets with the state changes. Let's try to visualize this a bit. So I came up with this graph. On the x-axis, you see the time. On the y, it's state, and then there are events. So until time t1, there is this state. It is representing the current state of the screen or the app, and then vModel produces this state, and inside the widget layer, this produces this purple screen. And at T1, we have an event, event B. We know that when event B happens, then the app state changes. This is state X. We know that when there is event P, it's going to change from Z to state X. This is defined, and your app will be orange. And then there is this event A. Your app becomes yellow with state Y. And then there is the event C. Your app is closed or your screen is closed. It's gone. Life cycle of it. And then this was the architecture part and state management entrance. Now let's talk about what I mean by MVVM. This is familiar. We don't have to talk about Flutter here. This is applicable to many frameworks and platforms. So MVVM and the model. Model is the structures and the behaviors in domain and data layers. It encapsulates the backend of the application. The business rules and data is processed to make decisions according to the specs defined by the business. And it abstracts the complexities of data operations. Then we have vModel. It makes sure that UI is decoupled from the business and data logic. So it transforms the data coming from the model into a form that it is easy to display by the view. And state management here is based on the user interactions and events, data changes. View processes the commands and then translates them to actions to be performed by the model. Then vModel receives updates from the model and translates them into the states so that we can show the widget tree. Okay, this was a lot of theory. And then finally, we have View. It captures the user actions, does not decide what to do, but forwards it to vModel and subscribe to the state changes and rebuilds. So this is something, again, I came up with to visualize things. We have screen A, and under that, we have a change notifier provider. This is from provider, how provider works. We have a vModel, and we mount the vModel, we bind it to the widget tree with change notifier provider widget. And under this, there is child widget C. This child watches the vModel, and then the state changes there. And something happens here. User touches the widget F, and on pressed, we are accessing to vModel here. It's the parent. And then we are calling vModel on widget pressed. Then in the next frame, vModel processes this event. It finds the corresponding state. And then widget C was subscribed to these changes in this vModel. And then widget E is updated. Widget F is replaced. Widget G, nothing happens because it's a const widget. So what you see in the UI changes based on the action captured in the view. vModel processed it and maybe communicated with the model and then produced another state which is visible in the new frame. This is the summary of how provider works. But yeah, this is from the demo app. Imagine this is the navigation drawer. When destination is selected, here, when the navigation destination is selected, you access the parent router vModel, and then you call the corresponding things, right? But this sounds a bit not consistent to what I told in the previous slide, because the view tells what to do to vModel. Instead, here we have the same navigation drawer. This is a bit refactor. I refactored this in the train today. So I was using this. As I said, every day I'm a better developer. And what happens when the destination is selected? We have the index, and based on the index, we know the destination, and we are just telling the router vModel that drawer destination selected. I don't care. I'm just a view. I can send you the events. This is a drawer. So this sounds like related to router. So destination selected. I don't care. And then vModel cares about it. So in the vModel, we have this method, we have this destination, and based on this, we built the navigation stack, because in our state, we have the navigation stack. We will come to this. Okay, so declarative navigation. This is very straightforward, right? Navigation stack, push and pop routes. This is Navigator Navigator 1. This was Turkish, yeah. Then Navigator 1, which is Navigator widget, has push and pop operations. It's very simple. It navigates between screens, pages, and models. So just holds the stack of routes and manages the navigation stack and operations. Navigator 2 introduces the router widget. This is also known as router API. And it's the core navigation orchestrator. It's declarative. It reacts to the changes in the app state and listens to OS intents. and updates the Navigator widget. So it's the parent of the Navigator widget. So Navigator 2 didn't bring Navigator widget, a new one. It is reusing the Navigator widget. It's backward compatible, but it introduces the router widget, which is the parent of the Navigator widget, and it is providing a framework that manages the navigation stack. Let's understand the Pages API, because Pages API is the one that you built the navigation stack. So imperative navigation operates with routes. You push and pop routes with Navigator 1. And then at Navigator 2, Pages API is introduced. It defines the desired state of navigation stack with a page object in a declarative way. So Navigator 2 didn't change the Navigator widget, but it added a field, which is a pages property. It has a list of pages. And then this page objects represents the current navigation stack. And this page list is transformed to the route stack. This should sound familiar because three important widgets of Flutter: widget tree, element tree, and render object tree. And widget tree has this create element method. When the widget is mounted to the tree, an element is created. Similarly, in the page there is this build method, there is this create route method, and Navigator 2 takes a list of pages and creates a route list. So it's also the same thing with the pre-Navigator 2 area, but it helps you to define things declaratively. This is an example. So you have a list of, like this is the home screen. You have a list of colors. And you see here, you have Navigator. We will provide pages depending on the state. So no matter what, we always have home page as the first page. And then declaration, this is a declarative. The app state is that selected color code is null. So if it is null, then we only have home page. But if it is not null, we are going to add this color page here. I press the button, no longer null. So we have the color page. We are going to the second page. And now selected shape border type is null here. But when I click one, it is no longer null. So we have 3 pages now. So this is declarative, depending on the state. So this is our famous architecture of Flutter. And we have framework, and then engine, and then embedder. Where we are working, we are here in the widgets layer. So Navigator API and Router API, it's all in the framework in the widgets layer. I'm going to talk about the Router widget because I said that it has a framework. Router widget is big because, as I said, navigation is a complex topic, especially for multi-platform. So Router widget has smaller parts, smaller classes inside that has certain responsibilities. This is the delegation pattern. So the first one is route information provider. And when a new URL, a location, and a state comes from the engine, this is moved from Flutter engine here to framework. And then it is the role of this router widget. So the component, the router widget delegates this to route information provider class to read the string and the state from the engine and then create a route information to be used in the framework layer. So what can this be? When you type the URL in the browser address bar, this needs to be processed in the Flutter engine, and then router widget inside the framework layer should use it in a way that it understands in the framework layer. And then another flow is that some internal thing changed in the app, and then you need to reflect this change to browser address bar. So URL changed. And this way, router widget informs the Flutter engine with this route information, and then Flutter engine uses this, parsing this, and then showing it in the address bar. But don't need to do anything with this because it is really standard. We don't even provide this. There is really rare scenarios. I haven't seen any. I can't come up with one. So this is by default implemented in the router widget, but you can still customize it. And then there is route information parser. This is converts the OS initiated route to a user-defined type. So you type your browser, you type something in your browser address bar. This needs to be processed in the Flutter engine, and then in the widgets layer, the router widget, we receive the new route information, and then route information parser parses this, and then returns the configuration back to router. Similarly, the app state changes, and then route information is parsed back to the engine. Then there is router delegate. This is the most important one because route information parser is needed usually when your app needs web support to handle the web browser address bar, also maybe deep links. But router delegate is a must if you are using Navigator 2. So it uses the current configuration received from route information parser and then builds the navigation widget, navigation stack. So it has a build method and it returns the navigator widget to the router widget. And then when the app state changes, it updates the engine. Then finally, the last component is the back button dispatcher. Android devices has this hardware button which causes pops and also these gestures. So these are operating system initiated pops. They are different than calling navigator pop. And this is handled with back button dispatcher. Okay, this is Navigator 2 in a nutshell. Looks good to me. But this is really complicated. I admit it is not when you are in it. It sounds complicated if I explain it in 5 minutes. But again, this is needed for really advanced scenarios. For example, in our Wolt model sheet package, open source package, we can change the bottom current visible model sheet page with the address bar. And then you see back button is pressed, the address bar is updated. So if you need this kind of a logic, you need to understand deeply how Navigator 2 works. But I'm going to show you a demo app. You don't need this complication. We only need to imagine you have an app that only needs to work in the mobile apps, doesn't process any deep links. Even if they process deep links, still don't need to do a lot of Navigator 2 work. You only need to understand the communication between router and router delegate. Router will tell the router delegate to build a navigator, and router delegate will give the navigator to router. Okay, a quick look how the demo app is. So we have the login screen. And then when you log in, you have the welcome screen because this is the first time the user enters. And if the user presses show me later, it will be shown again later. But if the user says show me the tutorial, it will go to the tutorial page. And then in the main screen, we have this coffee maker steps, grinding, adding water, and ready. When you are in add water, you press this card and it takes you this screen. And when this water stage is done, it goes to the ready. And the second navigation step is with the navigation drawer. You can log out, or you can go to this tutorials page, and then you can go to tutorial detail. A bit complex, not too complex. Okay, not too complex at all, but let's see how it is done. Okay, this is the material app. This is the app, the entry, almost the entry for all Flutter apps. So material app has this router constructor, factory constructor for easily integrating Navigator 2. And you don't need to provide the router widget explicitly if you use this constructor. You just provide the router delegate and back button dispatcher. And you locate the router V model with change notifier provider. This is your V model, and it is going to control the view, right? Easy. Then let's go into the router V model. It's a change notifier. It's the V model, but we need to inject the model inside it. In our case, model is authentication service and onboarding service. Initially, we provide if the user is logged in, if the tutorial is shown, we have this initial state. And when this V model is constructed, see we have this on init call. And this on init call subscribes to authentication events. And when it is disposed, it removes the listener. We have the state of the router V model. This state has a list of pages. This is the pages API. It's sealed class, so it is exhaustive. They all extend this app root page. Then the initial state. Let's focus on this initial state. So if it is logged in, we have the orders root page. This is the main screen. And if the tutorial model is not shown, it is going to show the model sheet because the model is actually a root. Otherwise, it's going to direct to the out root page. So this is declarative. And then let's focus on this authentication state changes in the V model. If it is logged in, again, the same thing actually. Yeah, should show tutorial or not. And then notify the listeners, which is the view. Master detail routing. Let's have a look at this master detail routing, especially in the tutorials page. So when the drawer selected, we have the destination. Okay, navigate the order screen. This is wrong. I think I forgot to update this part in the train today because view should, okay, wait, this is the V model, yes. So the V model is implementing on drawer destination selected. Then inside there is this private methods that takes you to order screen, tutorial screen, or logout. And when in the V model, again, we have this on tutorial details selected, then it navigates to single tutorial screen. And how it looks like, navigate to tutorial screen. You have the state, you are copying the pages, you are replacing the pages with the tutorials root page when you press this one. And when it is the navigate to single tutorial screen, again, your navigation stack looks like this. You have the first tutorials root page, and on top of that, single tutorial root page, and then you notify the view. The app rebuilds the navigation stack. So let's see how we manage the model root in a declarative way. Here, welcome. We are using Wolt model sheet here, and Wolt model sheet package exposes this custom root. And in this custom root, we capture on model dismissed with drag and on model dismissed with barrier tab. So you press here and you go take this down and close it, drag it. So this needs to be updated in the V model. So we need to understand these actions. Again, you are in the add water page. Here we have back button. In Flutter, you have default back button. It calls Navigator pop. It is an imperative call. But if your app is building the navigation stack declaratively, and then in your app, if you are using imperative navigation, you are mixing both, you need to somehow update it. And then this Navigator class has this on pop page field. So this captures all the imperative calls made in the app. And then here, for example, this add water page, you press the back button, and then I go to V model and I said that I call this method on page popped imperatively and providing the page name. And inside this V model, I take the necessary actions here and update the application state, which has the navigation stack. And then there is handling OS-driven pop. So again, in Android devices, there is this gesture. So Navigator 2 has this dispatcher, but router delegate implements this pop route method. So I capture here again on page popped with operating system. And then here I take necessary actions inside the V model. Finally, this is the last one. So there is this shortcut. It's a widget back button listener in the Flutter SDK. It has on back button pressed. So it captures in the widget layer these events. And then, for example, in this screen, I capture it. When the navigation drawer is open, I don't pop the app. So I don't pop the screen. I'm staying in the same screen. When there is this pop event caused by the operating system intent, I capture it and close the drawer. If the drawer is already closed, then I close the app with the pop. Okay, this was it. It was quite intensive. I don't know how you feel like Navigator 2, but if you have just a mobile app, it is that simple. It can be that simple. If you have a web app, then you are supporting more devices, and more is going to introduce even more devices. So it is getting a bit difficult to handle this. It's getting complex, but when you understand it, you can do it. Thank you.